Okay, so we're going to start a unit on trig now. And the first thing we got to talk about with trig is angles. Trig functions are all about angles. At this point in pre-calculus, many of you have probably taken some trig before, maybe have some experience with this, but I always like to tell people, you know, for many of you, it might have been a few years since you've done some trig. And anytime you don't use something for a while, we tend to forget it. So I'm going to treat this as if everybody has no experience with trig. So even if you do, could be just a review, I guess. So yeah, anyhow, you should start by just drawing a circle. Any size will do. And what we want to do is put our circle on the XY plane here so that we can define an angle. If you were at the center of this circle looking along the positive x-axis, then you would be facing an angle of 0 degrees. By the way, we'll talk about for angles can be measured in either degrees or what we call radians. And if you've taken any trig before, you're probably pretty familiar with degrees, maybe not so comfortable with the idea of radians. But it turns out when you go into calculus, almost exclusively we use radians for degrees. So part of this video is to help you get comfortable with radian measures. But let's start with degrees. So as I said, if you're facing the positive x-axis, you would be facing an angle of 0 degrees. And we have to decide which way we'll travel around the circle to develop a positive angle. And it's already been decided. Somebody already decided if we move this way, so counterclockwise, that is a positive angle. And if we move clockwise, that's going to generate a negative angle. So if we were to move in a positive way up to the y-axis, then the angle that is created from the positive x-axis and the positive y-axis. Many of you will recognize that as a right angle. And that's the same in degrees as 90 degrees. So if you were to rotate a quarter of a circle up here, that angle from here to here is 90 degrees. If you go 90 and then you do another right angle, putting you here halfway around the circle, that is 180 degrees. Keep going another quarter circle, you're going to be adding 90 degrees to that. If you rotate 3/4 of a circle, that's going to be 270 degrees. And one full trip around the circle is 360 degrees. Now, it's not correct to really say that 0 equals 360 degrees, but what we say is 0 degrees and 360 degrees are coterminal. That just means they end up in the same spot. I'll write that down here. Coterminal angles means you end up in the same spot. End up in the same spot on the circle. Okay, so that would be, 360 degrees, someone would know that the angle had already gone around the circle once. And you can go around the circle as many times as we want. So if one trip around the circle is 360 degrees, then 2 full trips around the circle would be 720 degrees, twice 360. That's twice around the circle. If you went around 3 times, add another 360 to that, you get 1080 degrees and so forth. You can go around the circle as many times as you want, but you can start to see the angles get very big every time you do that. I talked about negative angles. Most of the time we'll do positive, but for example, if we were to start at 0 and rotate negatively 90 degrees, we could say that 270 degrees is coterminal with negative 90 degrees, because that would put you in the same spot on the circle. Okay. But again, most of the time we'll go with positive angles. So let's talk about radians now. The circle we've drawn here has a radius. That's this distance right here. That is the radius of my circle. And how about I just denote that as capital R? So what a radian is, whatever the size of your circle, it has a certain radius. If you can imagine this length applied along the perimeter of the circle, if you were to travel the same distance, this distance here along the perimeter, I'm going to estimate here and say that this curve distance from here to here is the same as this. In other words, that's the radius of the circle applied on the outside. Whatever that is, where that stops, if you make an angle by drawing a straight line to the center, this angle right here, for angles, oftentimes we use theta. By definition, that angle is 1 radian. Or sometimes we'll just use capital R for that. We'll say that's 1 radian, like an exponent. So that's what a radian is. If you're curious in degrees, I mean, that looks like it's about 2/3 of the way from 0 to 90, and 2/3 of 90 is 60 degrees. It's about 60 degrees. I think it's more like 57 degrees is 1 radian. And that would be true no matter what the size of your circle is. The angle would still be this, 1 radian. Now, if you were to travel from here 1 more radian, I'm going to estimate maybe about this distance right here. Maybe I overshot it a little bit. From 0 all the way to this angle, that would be an angle of 2 radians. And if I were to do 1 more radian, I'm going to estimate that it's going to put me about right here. So this angle from here to here is 3 radians. So to get to 180 degrees, notice you would have to go 1, 2, 3, plus a little tiny bit to get to 180 degrees, half of a circle. So half of a circle in radians is approximately 3.14. There's more decimals there, radians, and some of you will recognize that. That is exactly what we call pi. In radians, 180 degrees and pi are the same thing. They put you in the same spot. That's a half of a circle. And when we use pi, it's understood that we're in radians, so we don't need to put the little r there. Okay, 180 degrees is the same as pi in radians. Now that we know that these are the same, that means 90 degrees is half of 180. So 90 degrees is the same as pi over 2. That's half of pi. This is 1 pi. So that means 270 must be the same as 1.5 pi, right? 1 plus another half. And in fractions, that's the same as 3/2 pi, or we sometimes mostly just say 3 pi over 2. And if you traveled a full circle, 360 degrees would be 2 pi. 0 degrees is 0 radians as well, 0 radians, but 360 degrees would be 2 pi radians. If 1 trip around the circle is 2 pi, that means 2 trips around the circle would be 2 pi plus another 2 pi. 720 degrees is the same as 4 pi. This is 3 trips around the circle. That's 6 pi. And you can see it's one of the nice things about radians, it's a lot easier to handle large angles, right? 1080 degrees is simply written as 6 pi. So that's one advantage of that. Okay, so one of the skills you want to be able to do is be able to convert back and forth between degrees and radians. So let's move this up. And our big conversion, I'm going to put conversion here, is we know that pi from up here is the same as 180 degrees. So let's say I want to convert to radians. Say I have 30 degrees and I want to convert that to radians. what I can always do to convert that to radians is if this is my conversion, I can multiply this by a fancy form of 1. If pi is the same as 180 degrees, then if I multiply this by pi divided by 180 degrees, that's like 1, right? And multiplying top and bottom by the same thing, then we end up getting, and you can think of this if you've taken chemistry sort of unit conversion, the degrees kind of cancel out there. So we have 30 pi over 180. And if we reduce that fraction, 30 goes into 180 6 times. That is pi over 6. So 30 degrees in radians is pi divided by 6. Let's try another one. If I had 240 degrees, my conversion, I'll still just multiply by pi over 180. I can think of degrees canceling. 240 pi over 180. I just need to reduce that fraction. 60 goes into both of those. 60 goes into 244 times and into 183 times. So in its reduced form, 240 degrees is the same as 4 pi over 3. So that's how you convert from degrees to radians. What I also should be able to do it the other way around. So say I want to convert to degrees. Let's say I had 18 degrees. I'm sorry, I want to convert to degrees. That already is in degrees. Let's say I have, how about this? Pi divided by, how about pi divided by 18? There we go. That is a radian measure for an angle. And if I want to convert this to degrees, I'm going to take the same conversion, but now I'm going to flip it. There's 180 degrees is the same as pi radians. And you can see the obvious reason to do that is the pi's cancel. And now I'm in degrees. Because remember, the units here were in radians. We didn't write them, but they're in radians. And so 180 divided by 18 is 10 degrees. Maybe one more. Let's say I have 7 pi over 4. You might want to pause the video and see if you can get that into degrees. So we'll times that by 180 degrees in pi radians. The pi's cancel. This one's a little bit tougher. You maybe will start with like 4. It's a little harder to see how many times 4 goes into 180, but certainly 2 goes into this twice and into 180 90 times. And 2 goes into 90 45 times. So that just leaves me with 7 times 45. If you do the math there, that comes out to be 315 degrees. All right, so hopefully this video, you can now, you understand what degrees and radians are and how to convert from one to the other.